Okay, hi everyone, welcome back to this video series on Cisco Packet Tracer, creating a custom device. If you require a router with a particular set of modules, it could be a daunting task to drag and drop modules each time before creating a topology. So Packet Tracer offers the features to save a device that you've customized as a custom-made device. Carry out the following steps to create a custom device. Drag and drop a network device in the work area. For example, we'll use a generic switch PT empty. Click on the switch and open its configuration dialog box and turn the device off. Add your most used modules to the switch. Navigate to Tools, Custom Devices dialog. Click on the select button and then click on the switch that was just customized. Provide a name and description and then click on Add and Save. This custom device is saved with a .ptd extension in user profile, Cisco Packet Tracer 6.1 templates. To make this custom device available to all users, copy it to %pt5 home %templates emulating WAN. To bring in more real-life scenarios, Packet Tracer has devices that emulate a WAN. Clicking on the WAN emulation cloud icon from the device type selection box lists the following devices. Cloud PT, this device looks like a cloud in the toolbar, but under the configuration window, it looks more like a router with several slots. The following modules are available for the cloud device. NM1AM. This module provides an RJ11 connector for connecting modems using telephone cables. The interface name of this module is modem N, with N being the port number. NM1CE, NM1CFE, NM1 CGFE. These modules provide an Ethernet, fast Ethernet, or gigabit interface respectively, through which devices connected to the modem and cable interfaces can be accessed except for speed. All three modules perform the same function. NM1FFE, NM1FGE. These two modules provide fast Ethernet or gigabit Ethernet for connecting fiber media. Functionally wise, they perform the same functions as the previous modules. NM1CX, this module has a coaxial connector for connecting a cable modem. NM1S, a serial port is available on this interface for configuring frame relay. The config tab for this interface provides options for creating frame relay mappings. DSL-Modem-PT. This is a modem with an Ethernet interface and an RJ11 interface. The Ethernet interface can be switched between Ethernet, fast Ethernet, and gigabit Ethernet. This device doesn't have any configuration options. Cable-Modem-PT. This modem is similar to the previous one, except that it supports a coaxial port. Accessing the CLI, the command line interface of a device in Packet Tracer can be accessed in two ways: the CLI tab or console port, although it is possible to access a device through SSH or Telnet. These are Cisco methods and are not exclusive to Packet Tracer. The CLI tab. This is the simplest way of accessing the command line interface of a device. Click on a network device, navigate to the CLI tab, and you'll see the booting process, the console port. There is no difference between what is seen and controlled in this method and the previous one, but the console port can be used to make the topology look similar to the real world. Follow the steps to configure the console port. 1. Add a PC or a laptop to the workspace. 2. Choose connections and then click on the console cable. 3. Connect the console cable to the network device to the RS23232 port of the PC laptop. 4. Open the PC laptop, navigate to the desktop tab, open terminal, and then with the default settings, click on OK to view the console. The following screenshot displays a router's console through its terminal. In step 2, if you use the automatically choose connection type option, the Ethernet ports of both of the devices will be connected. Configuring network devices. In this section, you'll learn how to configure Cisco routers and switches without using a single command. Yes, it is possible. Packet Tracer provides a config tab that contains GUI options for the most common configurations. What's more, as you tinker with the GUI, its equivalent Cisco iOS command is also displayed. Take a look at the following screenshot. From the config tab of the switch, we will set the interface option to fast Ethernet 0/1 and uncheck the uncheck box for port status. So the equivalent iOS commands section displays the following command to achieve this process: switch enable, switch configure, terminal, switch config, interface fast Ethernet 0/1, switch config, shutdown. Using the config tab, the following can be configured: global settings, routing on a router and a layer 3 switch, VLAN database on a switch, interface settings. Let's see what happens. Let's see what options are offered under each of these sections. Global settings. The first part of global settings allows you to change the display name and host name of the device. The display name can also be changed by clicking on the name below the device icon. The configuration file for the device can also be saved, erased, or exported for later use. The algorithm settings section contains settings meant for advanced users who want to minimally tweak their device to see how it responds to certain situations. These settings can also be globally set for all network devices by navigating to options, algorithm settings, or by using shortcut Control-Shift-M routing. This section has options for configuring static and dynamic routing, RIP. To configure static routing, enter the network address, net mask, and its next hop address, and then click on Add. Here is some simple network information: network 192.168.30.0, mask 255.255.255.0, next hop 10.0.0.6. To configure routing information protocol, RIP, it is enough to add only the network IP. Please note that the GUI uses RIP version 1. So classless routing is not supported. Apart from routers, routing can also be configured on the 3560/24 PS switch, as it is a layer 3 switch, VLAN database. This section will teach you how to create, remove VLANs. VLANs and trunking are discussed in Chapter 10, configuring VLANs and trunks. Only the VLAN database can be modified from these options. Adding interfaces to these VLANs is what we'll see in the next section, interface settings. This section slightly differs from the switch and the router. Switches have options for modifying the speed and duplex setting and for assigning a port to VLAN. On routers, the VLAN section is replaced by the IP address configuration. While changing the speed and duplex settings. If you are setting it into anything other than auto, make sure that the settings are same on both ends. For example, if you set it to 100 Mbps on one end and 10 Mbps on the other, the link won't come up. Summary: in this chapter, we learned all about network hardware devices and their modules, along with each one's features, limitations, and their naming convention. We have also seen the methods through which CLI can be accessed. By now, you will have been able to configure these devices with just the GUI. If you are the adventurous kind, go ahead and try creating a simple topology with a couple of routers and PCs residing in different logical networks. In the next chapter, we'll learn about end devices in Packet Tracer. The options in the config tab of the devices will also be explored. You'll be surprised to see the number of devices available. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.